Hey there, I'm Yako, and this is the video I've been looking forward to making. I don't often make videos about concrete frameworks and features, but this time I take a different approach and do exactly the opposite. Today I'll be exploring a framework that is so new you literally couldn't use it just a couple weeks ago, at least without jumping through some hoops first. The framework is Swift testing. It was announced at WWDC back in June, and if you watched my overview of the conference, you could probably see how excited I was. Well, I've had plenty of time to try Swift testing over the past few weeks, and I gotta say, now I'm excited even more. So, without further ado, let's dive in. And let's start with the things that are new or different in Swift testing. The framework obviously has something to do with automated testing. If you're completely new to this concept as a whole, I can refer you to this video I made. I also have a GitHub repo which demonstrates the key concepts I was talking about in that video. And after this video, I'll push a separate branch where I switch the demo project to Swift testing. If you know a thing or two about automated testing in Xcode, then you certainly know that it already ships a framework for that. XCTest has been available for many years. In fact, it predates Swift itself. And that, in my opinion, is one of the reasons why Apple decided to develop an all-new framework. You see, XCTest is deeply tied to the concepts coming from Objective-C, and even from C itself. In Swift, some of them may look kinda out of place, and this can be pretty confusing. Like those assertion macros, for example. Things like XCT_assert equal or XCT_assert not identical. In Swift, you don't often see such things, so they might need some getting used to. But if you expect Swift testing to offer a radically different approach to writing tests, then you'd be wrong. Of course, that doesn't mean its changes are insignificant or excessive, but most of them are simple quality of life improvements, rather than a complete overhaul. First of all, Swift testing is designed to be a drop-in replacement for XCTest. You change just a few lines in your test suites and you're ready to go. But if that was it, it wouldn't justify creating a whole new framework, I think. That is why Swift testing ships a number of other changes. The good news is that you can embrace them one by one. You're not really pushed to jump ship at once. But in this video, I'd like to highlight more features of Swift testing than just its overall Swiftification. The first thing you'll notice when you start using Swift testing is that it heavily relies on Swift macros. They are relatively new to the language. Macros were introduced a year ago, and I did a video about them. 2 videos actually. In those videos, I explained how they improve the development workflow. Swift testing relies on macros from the very beginning. When you want to declare a test method, instead of starting its name with test as in the old framework, you simply attach the test macro to the function. The same macro can be used to further configure the test, and I'll get back to those customizations in a minute. But in basic cases, that's not even necessary. Another thing that's not necessary in Swift testing is test classes, or suites. Previously, you had to keep all your test methods in a subclass of XCTest case. Now you can declare them right away as global functions. There are test suites in Swift testing though. They are helpful for test organization, or when you want to make your tests run one after another, because by default they run in parallel. Test suites are also declared with macros, but again, you don't strictly need them. Tests work just fine even without suites. Speaking of the actual tests, the most prominent thing that changed is how you check the results and expectations. Previously, you were offered a bunch of XCT_assert macros. Some for booleans, some for optional values, some for equatable objects, and so on. Those were C-style macros, and Swift testing replaces them with the new expect expression. It's a Swift macro, as you can see from its syntax, and this macro is used in most places where you'd normally put an assertion. Instead of specialized versions for different kinds of data, expect is a universal thing which you use everywhere. You just need to make your expression evaluate to a boolean. Besides expect, there's another macro you might need from time to time. It is the require expression. You see, typically you want your test to collect as much information as possible in a single run. And that is why when expect fails, it doesn't stop the test, but only records an issue for the report. But in some cases, that's not what you want. For instance, if your production method returns an optional value, it doesn't make much sense to proceed with testing if the value is nil. Require does exactly that. If its condition fails, require immediately stops the test and notifies you. That's why it is a useful tool to unwrap optionals and tests. This macro can actually return an unwrapped non-optional value, which you then check with expect. If you wanted to do the same in exitest, you had the exit assert not nil assertion. But it only checked the value, it didn't unwrap it. So when you needed an actual value, then your code quickly started to look hideous. Even though these changes are very welcome ones, I still wouldn't call them enough of a reason to create a brand new framework. Then what is? In my opinion, it's parameterized testing. How often do you have to write tests which differ by only a couple characters? Maybe you're testing a method which works with numbers, and you want to make sure it works correctly with values large and small, positive and negative, and so on. In exitest, you generally have two ways to implement this. First, you can copy and paste the test method multiple times, and then update the values. This is tedious to write and hard to maintain. You're constantly risking forgetting to update some values. Second, you can use something like a for-in loop to check multiple inputs within a single test. This is shorter and easier to write and maintain, but I wouldn't say it's easier to use. You see, if the test breaks, you'll have no idea which input value caused the failure, so you'd need to check them one by one. What people typically do is comment all inputs, then uncomment them one by one, and launch the test over and over again. Parameterized testing basically duplicates the test method behind the scenes. You write it just once, and Swift testing emits a separate copy for each parameter you pass. You're not limited to a single parameter per test instance. You can, for example, pass them in pairs, the input value and the expected result. Best of all, your test method looks just like a normal function. This feature is, once again, based on Swift macros. The big advantage of this approach is that when one of the virtual tests fails, you'll know exactly which input value is to blame. Xcode will even show them as separate test methods in the report. Next is probably my favorite feature of Swift testing. It is error matching. When you design your API, in many cases it makes sense to throw an explicit error, as opposed to returning nil or failing silently. This way, both your production code and test methods can get a hint of what went wrong. When you test throwing methods, you normally want to make sure that they throw not just any error, but the specific one that was expected in a given scenario. Exitest doesn't really give you any out-of-the-box tools for that. You can check that an error was in fact thrown, but when you want to go beyond that and check the specific error value, you typically write code which is pretty easy to mess up. Just look at it. Here, for instance, I cast the existential error type to the error I'm expecting. If casting fails, I should return from the method. But this code doesn't do what I want, because returning from a test method is considered a success. I have to call exitFail explicitly, and I have to keep that in mind in every test. Swift testing, on the other hand, handles this scenario automatically. The very same expect macro can verify everything with just a single expression. It makes sure that an error is thrown, checks its type, and can even match against the specific error case. All of that with no typecasting, no manual checks, and no explicit failures. There are more complex cases, of course. For them, you have another version of expect, where you have a closure to evaluate the error. And while I was updating the demo project, I found something which to me looks like a bug. Apparently, this expression is fine, while this one fails to compile, even though they are more or less equivalent in normal Swift code. Now that we're clear about the key changes Swift testing ships, let's have a look at a few more features. These are supposed to help you organize, run, and maintain your tests over time. In Exitest and many other testing frameworks, test methods related to a single component are typically grouped together in a suite. Swift testing doesn't require you to do that. It's perfectly fine with standalone test methods. But using suites has a few benefits. First, it helps you organize the tests in a way that makes sense. With suites, you can run only a subset of tests, without waiting for the rest of them. Unlike in Exitest, suites in Swift testing don't have to inherit from a specific base class. In fact, they don't have to be classes at all. You can use structures and enumerations just as well. I prefer structs because they let you declare instance variable for helper objects, such as mocks, stubs, and so on. One important distinction between suites in XCTest and Swift testing is how they're used during test runs. XCTest initializes the test case class only once, and then it reuses this single instance for every test method. But Swift testing creates a new suite for each individual method. That means you don't have to worry about its state between the test runs, and you don't need methods such as setup or teardown. One thing you won't find in this code snippet is any sort of explicit suite declaration. That's because it's not there. Simply enclosing test methods in a struct enum class is enough to create a suite actually. However, there is the suite macro which you can attach here. It's not necessary, but it gives you a few more customization options. First, you can give the suite a more informative name, which will appear in the organizer and test reports. Second, you can pass one or more traits. For example, you can disable the suite altogether or conditionally. You can also make tests run sequentially, one after another, because by default they run in parallel, and that's a big change from how things were in XCTest. With traits, you can set a timeout, leave a link to your bug tracker, and do other things. Many of the suite traits can be applied to individual tests, and vice versa. One exception to that principle that I found is conditional availability. Apparently, if your test should run only in some OS versions, you need to mark individual methods. The available attribute doesn't work with suites. This looks kinda strange to me, especially given that this attribute also doesn't work with stored properties. In other words, if you're testing a component which is not available in some versions, you'll want to stick with XCTest for now. One more trait that I'd like to highlight is tags, because I think it's quite a big deal. In Swift testing, suites are not the only tool you can use to organize tests. Tags are a new concept, which lets you group tests across different suites and different source files. For instance, this way you can assign priorities to individual tests. So when some of them fail, you can focus on fixing the most critical ones first. As powerful as Swift testing is, there's a couple scenarios where you can't use it, right now at least. But testing Objective-C methods is not one of them. You can write tests which call into Objective-C code just fine. You do that basically the same way you write production code. However, tests themselves must be written in Swift. There are cases where testing some code requires using Objective-C. For example, when you need to import a private header with some hidden symbols. In situations like this, Swift testing can help you right now. Another situation where Swift testing can help is when you want to test your app's user interface, or employ any other kind of UI automation. UI testing is not supported at all right now. Maybe it will arrive in a future version, maybe it won't. But for now, you'd have to keep on using XCTest, or something else, if you prefer snapshot testing for example. Measuring your code's performance is also not supported as of today. XCT metric and other performance APIs are not yet available in Swift testing. Also, I already mentioned that some features I used did not behave as expected. I tend to think it was just a bug which can be fixed, but there may be more. Since Swift testing is very new, it can take a while for it to mature and become fully reliable. One feature of Swift testing that I'm especially excited about is that it's open source. You can browse its code on GitHub, make contributions to it, or fork the repo for private use. Maybe you can even fix the issue that I had in my demo. Or maybe I can. The open source nature makes Swift testing easier to customize and more transparent to debug. Well, Swift testing is not only open source, but it's also cross-platform. It supports macOS, Windows, and Linux. This ain't something entirely new, because XCTest has been available on other platforms for years. But this is a step forward, because right now all variants of Swift testing are built from the very same codebase. This should make them equivalent in terms of features and behavior. In this video, I highlighted the key changes and updates Swift testing delivers. In summary, while there is a number of improvements over XCTest, the new framework doesn't really change the fundamental principles of automated testing. The new expect and require macros provide a concise and expressive way to check values, unwrap optionals, and match errors. Test suites and individual tests can be customized with traits in many different ways. Tags are another way to organize your tests in groups, even if they reside in different suites. And of course, parameterized testing saves you a lot of time and effort in writing, running, and maintaining tests. In short, Swift testing brings a lot of welcome improvements, but without reinventing the wheel. I'd say it is my favorite announcement from this year's WWDC. I encourage you to give it a try, and you can find an example in the repo that I linked in the description. Thanks for watching. As always, if you have any questions or comments, feel free to leave them below. Be sure to subscribe to the SwiftBird for more videos about Swift and software development. I'll see you soon. Until then, make your tests fly.